First, this is UV radiation. UV radiation ಯಾವ ರೇಂಜ್ ಅಲ್ಲಿ ಇರುತ್ತೆ? ಎನರ್ಜಿ C is equal to SC by lambda. Lambda is 200 nanometer. This comes and then it comes study under reason. ಆಯ್ತಾ? ಫಸ್ಟ್ ಒಂದು ಸ್ಯಾಂಪಲ್ ಯಾವ ತರ ಅಬ್ಸರ್ವ್ ಆಗುತ್ತೆ medium at right angles to the plane of surface. At right angle to the transmitted light decreases transmitted light decreases exponentially as the thickness ಅಂದ್ರೆ ಇದು.
Excuse me, sir.
ಹೇಳಪ್ಪ.
Sir, your voice is not clearly audible, sir. Excuse me, sir.
ಈಗ
Clear ಇಲ್ಲ sir.
Whenever you pass a light, means when a light passes through absorbing medium, the rate of decrease, ಇದು decrease ಆಗುತ್ತೆ. It observes, definitely it observes this incident radiation I0, and this is transmitted. ಆಯ್ತಾ? So it absorbs some radiation, absorbing medium. The intensity of transmitted light decreases exponentially as the thickness of the medium, as the thickness of the medium increases arithmetically. So the definition very important. The definition: when a light passes through a absorbing medium, the rate of decrease of transmitted light decreases exponentially as the thickness of the medium increases arithmetically. Aita? So this is accordingly in the mathematical way. Accordingly, Lambert's law can be stated as follows. So Beers and Lambert's law. This is total definition of transmitted light decreases exponentially with increasing thickness ಅಂತ ಹೇಳಿದ್ದು Beers and Lambert's law. According to only Lambert's law, according to Lambert's law can be stated as follows: when a beam of light is allowed to pass through transparent medium, this is a transparent medium. When a beam of light is allowed to pass through transparent medium, the rate of decrease of intensity with thickness of medium is directly proportional to intensity of light. The intensity of thickness of medium is directly the intensity with thickness is direct, means dI by dt. Incident light with respect to thickness is directly proportional to intensity of light. Mathematically, Lambert's law may be expressed as follows. Means this is minus di by dt. So this di ಆಯ್ತಾ. This I incident and this is thickness IT. So minus di by dt dA by dt is equal to Ki, where K is proportionality constant. A is proportionality constant. Proportionality constant. What about I? Incident radiation. This is incident, right? I is incident radiation. I is incident radiation. Incident of intensity of incident light. Incident light. I is intensity of incident light. Is mainly depends on di by dt. Andre the change in intensity with respect to thickness is directly proportional to incident light. Incident light. So this is 1. And what about T? T andre enili dt. T is thickness. T is thickness. So this is thickness, proportionality constant, incident light. The incident light decreases with respect to thickness is directly proportional to intensity of incident light. This is according to Lambert's law. So integrating on both sides, if you integrate this one on both sides, we can call this equation 1. So integrate ಮಾಡಿ ಎರಡು equation on both sides. So integrate ಮಾಡೋದ್ರಿಂದ you'll get minus di by dt is equal to Ki. I2 I0 and this one 0 to t. 0 to t. So you'll get rearrange this one di by I and 0 to t into K dt. So ಈ I ನ left side ತಗೊಂಡಿದ್ದೀನಿ. So this is I2 I0 minus log. What about integration of 1 by I or 1 by x? You know this mathematics, 1 by x is log x. 1 by x is log x. So minus log I to I0 is equal to K T 0 to T. So minus log upper limits minus lower limit is equal to upper limit KT minus K into 0, so lower limit. Minus not by I. This is the mathematical transformation. ಕ್ಲಾಸ್ ಕೇಳಿಸ್ತಿದ್ಯಾ? ಮಾತಾಡಿ ಯಾರಾದ್ರು.
Sir, you are audible.
ಓಕೆ. ನೋಡಿ, Beer's law ಅಂದ್ರೆ, so what is Beer's law? Beer's law is nothing but the intensity of incident light and this emitted light is directly proportional to concentration. So absorbance ಇದೆಯಲ್ಲ is directly proportional to concentration. Is directly proportional to concentration. This dI naught by dC is directly proportional to intensity. Andre decrease in concentration, decrease or increase. Absorbance is directly proportional to C. So absorbance is equal to log of transmittance andre exponentially log of, so I naught e to the power of AD with here CT. So ಇಲ್ಲಿ K ಬದಲು F naught ತಗೊಳ್ತೀನಿ. So I naught exponentially with constant thickness ಏನದು Lambert's law, concentration decreases ಆಗೋದು by Beer's law. Now combining this is called Beer's-Lambert's law. Beer's-Lambert's law. ಆಯ್ತಾ? ಟೋಟಲ್ ಕಾಂಬಿನೇಷನ್ ಏನು? Beer's-Lambert's law. So log I naught by I. So whatever T is equal to log T. T is nothing but transmittance. So transmitted light T is I naught by I. The transmitted light is incident divided by emitted light. So absorbance is equal to log of transmittance andre exponentially log of T, that is whatever T is nothing but log I naught by I. Absorbance is equal to log, absorbance centrally, then absorbance. ಇದನ್ನೇ ಈ ತರನು ಬರ್ಕೋಬೋದಲ್ವಾ? I is equal to I naught by I naught it is power of absorbance. So ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಮೈನಸ್ ಬರ್ದಿಲ್ಲ. ಸೊ ಮೈನಸ್ ಬರೆದ್ರೆ ಇದು ಈ ಕಡೆ ಬರುತ್ತೆ. So I is equal to I naught minus A. What is minus? A is what? F naught CT. See? So this is the Beer's-Lambert's law. So this is log T. Log T is equal to I naught by IT if A is equal to log 1 by T is equal to log I by I naught, log I by I naught, I by I naught, that's equal to what? Minus log T. That's equal to minus log T. Final absorbance is equal to what? Minus log T. Absorbance is equal to minus log T. So this is where T is transmitted light to that of incident light. So instrumentation, this is this theory actually. So you have to read. I had given in SLM instrumentation. Work for it. Next topic is theory of UV visible spectroscopy. So theory is not just H mu. Theory of UV spectroscopy. UV spectroscopy. What is the theories involved in the UV spectroscopy? The theory is ultraviolet visible spectroscopy is an electronic transition spectroscopic technique in which the interaction between incident radiation and electrons. Incident radiation, so is energy level. Organic molecularly, so incident radiation with interaction with incident radiation and electrons. Incident radiation with electron results in the promotion of one more excited to here. This excited, so promotion of one or more outer are the bonding electrons. So outer are the bonding electrons to higher energy level. From ground state into higher state, this effect results in the specific absorption of radiation, the frequency and wavelength. What is frequency? Sc by lambda is equal to velocity of light is velocity of light. Lambda is energy level from ground state to higher energy state. This is the so UV spectroscopy mainly deals with interaction with light and electrons of organic molecule. Bonded electrons ಮತ್ತೆ H mu ಅಂದ್ರೆ light radiation ಮತ್ತೆ bonded electrons interaction ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ಆಲ್ರೆಡಿ UV spectroscopy. Are possible. Remaining two are 5 bonds. See, okay. 2 non-bonded. So this is non-bonded electrons. So when a molecule is exposed to UV radiation, when a molecule is exposed to UV visible light, the absorption of energy taking place as a result of this absorption takes place. Energy levels absorption takes place as a result of this sigma to sigma star, sigma to sigma n to it's like this. See, this is the energy level. This diagram is very important for your examination. So this is energy and this is first sigma bond, pi bond, non-bonded, pi star, and then sigma star. The first one, sigma to sigma star transition. So one radiation na electron ಒಂದು ಬಾಂಡೆಡ್ ಯಾವುದೇ ಒಂದು ಎಲಿಮೆಂಟ್ ಅಸಿಟೋನ್ ತಗೊಳ್ತೀನಿ, ಎಲ್ಲ ಇದೆ ಇಲ್ಲಿ, ಪೈ ಇದೆ, ಸಿಗ್ಮಾ ಇದೆ, ಎಲ್ಲ ಇದೆ. ಸಿಗ್ಮಾ ಬಾಂಡೆಡ್ ಅಲ್ಲಿ ಎನರ್ಜಿ ಈ ತರ ಎನರ್ಜಿ ಸ್ಪ್ಲಿಟ್ ಆಗಿರುತ್ತೆ ಬಾಂಡಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಸೊ ಫಸ್ಟ್ ಸಿಗ್ಮಾ ಟು ಸಿಗ್ಮಾ ಸ್ಟಾರ್ ಒನ್ ಟೈಪ್, ನೆಕ್ಸ್ಟ್ ಎನ್ ಟು ಸಿಗ್ಮಾ ಸ್ಟಾರ್ ನಾನ್ ಬಾಂಡೆಡ್ ಟು n to sigma star, and then pi to pi star, pi to pi star, and then n to pi star, n to pi star. So these are the types. So n to sigma star kuda ide. See, this is n to illu agutte. These are the major. This n to sigma star is very less compared to remaining. Pi to sigma star agutte. Pi to sigma star. Pi to sigma star. Idu ide. These are very less. But the major is pi to sigma to n to sigma star, pi to pi star. So this is the types of transition. So first case I will take sigma to sigma star. Sigma to sigma star. Sigma to sigma star transition. See, sigma to sigma transition. Sigma to sigma transition here. So this is sigma to sigma transition. Sigma to sigma transition. Aita? Take place when sigma electron get promoted to antibonding. Star is nothing but antibonding sigma star orbit. It represented as sigma to sigma star. This is represented as sigma to sigma transition. The energy required for this transition is very high. See, energy gap is very high here. Not the highest energy. It requires very high energy. High energy is required for this sigma to sigma transition. For example, methane. All the bonding electrons are in the sigma. Ella sigma bond ilida. Methane example. So CH bond can only undergo sigma to sigma star transition. So an absorption maximum at 125 nanometer. 125 nanometer. Absorption maximum. So absorption maximum 125 nanometer. So absorption maximum due to what? Sigma to sigma star transition are not seen in the UV. ನೀವು UV ಸಪ್ಲೈ ಮಾಡಿದ್ರೆ ಮೀಥೇನ್ಗೆ ಸಿಗ್ಮಾ ಟು ಸಿಗ್ಮಾ ಟ್ರಾನ್ಸಿಷನ್ is not seen because it should come 200 to 300 nanometer. ಈ ರೇಂಜ್ ಅಲ್ಲಿ ಬಂದ್ರೆ ಮಾತ್ರ UV ರೀಚಬಲ್ ಕಣ್ಣು ಕಾಣಿಸುತ್ತೆ. UV ವಿಸಿಬಲ್ ಆಯ್ತಾ? UV ವಿಸಿಬಲ್. UV ರೇಂಜ್ ಬರಬೇಕು ಅಂದ್ರೆ 200 to 300 ಬರಬೇಕು. ಬಟ್ CS for absorption at 125. As a result, this transition not seen in the typical UV spectrum. Aita? Next, N2 sigma star. Next, I'll take N2 sigma star. N2 sigma star transition. So this is ನಾನ್ ಬಾಂಡಿಂಗ್ ಇರಬೇಕು. ನಾನ್ ಬಾಂಡಿಂಗ್ ಇರಬೇಕು ಅಂದ್ರೆ ಒಂದು ಹೆಟೆರೋ ಟೈಮ್ ಇರಬೇಕು, ಲೋನ್ ಪೇರ್ ಇರಬೇಕು. ನಾನ್ ಬಾಂಡೆಡ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಲೋನ್ ಪೇರ್. So N2 sigma stars take place when N electrons get promoted to an antibonding sigma orbital. It represents N2 sigma star. It represents N2 sigma star. See, this N2 sigma star transition. These transitions usually need less energy. See, compared to this sigma to sigma, less energy than sigma to sigma star. This is less energy than to sigma star energy. Right? They can be initiated by light whose wavelength in the range 150 to 200 nanometer. 150 to 200 nanometer. The number of organic functional groups with N2 sigma star in UV regional is small. Actually, it is the N2 sigma star also very rare. This type of transition also is very rare. The next, pi to pi star. Next, pi to star. Here transition takes place when pi star transition. Transition occur in a compound containing conjugated system. Conjugated system, say pi bond. Conjugated system. The bond origin due to pi to pi star transition. Due to pi to pi star transition. The bond origin due to pi to pi star transition is called, this is also ಈ ಬ್ಯಾಂಡ್ ಏನಂತ ಕರಿತೀವಿ, it's also called K band. Pi to pi transition is also called K band. It's also called K band. Compounds like diene, enons, ನೋಡಿ CS2, CS3. enon ನಲ್ಲಿ ಕೀಟೋಯಿನಲ್ ಟಾಟಮರಿಸಮ್ ಕೇಳಿದಿರಲ್ವಾ? This is O minus CS2 enon. ಆಯ್ತಾ? So etc. So like this, these are conjugated polyenes. Polyenes andre, so these are polyene. The intensity of is also K bands also appear in aromatic compounds substituted by chromophore. Pi to pi star transition is also called K band. Is also appear in aromatic compound substituted by chromophore. Any donating group is means chromophore. So if any group which enhances the intensity of UV light, UV absorption, then this is called chromophore. The intensity of K band is usually more than 10 to the power of 4 intensity. The K band absorption due to conjugated enes, like conjugated, due to conjugated enons are affected differently by changing the polarity of the solid. Sometimes it changes with polarity of the solid. ನೋಡಿ absorption ಇದು, absorption butadiene pi to pi star transition, lambda maximum, see ಹೇಳಿದೆ 200 is almost UV visible, so UV is 200 to 300. ಆಯ್ತಾ? acrolein compound, this is also pi to pi star. So this is also pi to pi star. This is 210. Styrene andre idu. This is styrene. Acetophenone. Right? So this was the compound. So CS3, CO, CS3, acetophenone. Same pi to pi star this also. Acetophenone 240. So many examples is there. Like this comes in the UV region. So pi to pi star is also called K band. The fourth type is N2 to pi star transition. N2 pi star. The molecules kuda ashte important. Double bond idre pi to pi star, N2 pi star next. So transition takes place when bonding heteroatoms electron gets promoted to an anti-bonding pi orbital. This type of transition requires least amount of energy among all the these transitions occurs, but the least energy to pi star compared to more, but very high. So least energy, say sigma to N2 pi star is less energy, increasing order. After that, then star. After that, pi to pi star, n to sigma star, then sigma to sigma star. See, this is they will ask transition. See, energy gap is very less, n to pi star, then pi to, after that n to sigma star, then sigma to sigma star. First, and now presently I am discussing now n to pi star type. So this type of transition least amount of energy is required here. So this occurs at longer wavelength. See, h c pi lambda. So wavelength increases, energy decreases. So wavelength increases what? So numerically there. So inversely proportional. Increases, energy decreases. So energy, very less energy is required. Less energy means more wavelength. Less energy is required. So wavelength ಏನಾಗುತ್ತೆ longer wavelength. Saturated aldehyde. See, this is an aldehyde. Saturated aldehyde. Type of transition, say aldehyde for example. So here n to pi star and also pi to pi star. ಇಲ್ಲಿ pi ಇದೆ. So pi part ಇಲ್ಲಿ pi ಇರೋದ್ರಿಂದ pi ಎರಡು ಲೋನ್ ಪೇರ್ ಇರೋದ್ರೆ n to pi star. n to pi star and pi to occurring around so this is 290 nanometer, 290 and 180. This is 180 millimicron meter. So this is low energy n to sigma star and high energy pi to pi star. Low energy, here we have observed pi to pi star and sigma to sigma star. What is the energy here? Occurring around 290 micron, the millimicron, and this is 180. So this is very low energy. This is a negative there. Micron means 10 to the minus 6. So value is just kadame. So this is high energy. So absorption occurred at lower wavelength. So lower wavelength ante absorption occurs at lower kadame irbeku wavelength. This is usually intense. So energy gap kadame irodrinda very intense. Absorption. So very intense. Absorptions occurring at lower wavelength is usually intense. Hence it is quite easy to tell whether the transition is n to pi star or pi to pi star. If the n to pi star is n to pi star anta ಯಾವ ರೀತಿ ಹೇಳ್ತೀವಿ, if it is the absorption is more intense, it has two peaks ಇರುತ್ತೆ. ಎರಡು peak ಬರುತ್ತೆ. Very less intensity, that is pi to pi star. This is n to pi star, more intense. That's why you can easily distinguish this is pi to pi star and this is n to pi star. Because of more intense, you can easily say this peak is n to pi star transition. N to pi star transition. Most absorption spectroscopy of organic compounds is based on transition of n to pi star transition. The organic compound is based n to the absorption peaks for the transition experiment convenient reason. ಸೊ ಯಾವ ರೀಸನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಇದೆಲ್ಲ 200 to 700 ನ್ಯಾನೋಮೀಟರ್. ಸೊ 200 to 700 ನ್ಯಾನೋಮೀಟರ್ ರೇಂಜ್ ಅಲ್ಲಿ ಯಾವ್ದು 5 to 5 ಸ್ಟಾರ್ ಮತ್ತೆ N to 5 ಸ್ಟಾರ್ ಅಂಡ್ ಈ ರೇಂಜ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ದಟ್ಸ್ ವೈ ಇಟ್ ಈಸ್ ಫಾಲ್ ಇನ್ UV ರೀಸನ್. ಈ ಟ್ರಾನ್ಸಿಷನ್ ಏನಕ್ಕೆ ಈ ರೀತಿ 100 to 700 ನ್ಯಾನೋಮೀಟರ್. ಈ ಟ್ರಾನ್ಸಿಷನ್ ನೀಡಿ ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಗ್ರೂಪ್. ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಅಂದ್ರೆ ಡಬಲ್ ಬಾಂಡ್. ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಗ್ರೂಪ್ ಇನ್ ದ ಮಾಲಿಕ್ಯೂಲ್ ಟು ಪ್ರೊವೈಡ್ ದಿ ಪೈಲಟ್ ಏನಕ್ಕೆ ಬೇಕು ಅದಕ್ಕೆ. ದ ಮೋಲಾರ್ ಅಬ್ಲಿಫ್ ಫ್ರಮ್ N to 5 ಸ್ಟಾರ್ ಟ್ರಾನ್ಸಿಷನ್ ಆರ್ ರಿಲೇಟಿವ್ಲಿ ಲೋ. N to 5 ಸ್ಟಾರ್ ಇದೆಯಲ್ಲ ಇಟ್ಸ್ ರಿಲೇಟಿವ್ಲಿ ಲೋ. ಇಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಫಾರ್ ಲೋ. ಇದು ಲೋ ಯಾವಾಗ ಯಾಕೆಂದ್ರೆ ಇಟ್ ರಿಕ್ವೈರ್ಸ್ ಲೆಸ್ ಎನರ್ಜಿ ಆದ್ರೂ ಬಟ್ N to 5 ಸ್ಟಾರ್ ಇಟ್ಸ್ ಬಿಲೋ 200 ನ್ಯಾನೋಮೀಟರ್ ಇರುತ್ತೆ. UV ರೀಸನ್ ಅಲ್ಲಿ ಬರಲ್ಲ ಇದು. ನಾ ಹೇಳಿದ 140 ಈ ರೇಂಜ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ದಟ್ಸ್ ವೈ ಇಟ್ ಇಸ್ ಫಾರ್ಬಿಡನ್ ಬ್ಯಾಡ್. 5 to 5 ಸ್ಟಾರ್ ಇಸ್ ಅಲೌಡ್ ಬಿಕಾಸ್ ದಿಸ್ ಕಮ್ಸ್ ಬಿಟ್ವೀನ್ 200 to 700. That's why it is forbidden band. The originate due to N to 5 star called R band. ಎಕ್ಸಾಂಪಲ್ ಕೇಳ್ತಾರೆ ವಾಟ್ ಈಸ್ ಆರ್ ಬ್ಯಾಂಡ್ ಅಂತ ಕೇಳ್ತಾರೆ. ಆರ್ ಬ್ಯಾಂಡ್ ಅಂದ್ರೆ N to 5 ಸ್ಟಾರ್ ಅದನ್ನ ಅಂತ ಕರಿತೀವಿ. 5 to 5 ಸ್ಟಾರ್ ಇದ್ರೆ K ಬ್ಯಾಂಡ್ ಆಯ್ತಾ, K ಬ್ಯಾಂಡ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ these are the types of transition. So N to 5 star ಅಲ್ಲಿ N to 5 star acetone, N to 5 star acetone, acetaldehyde, the compound, acrolein, acetophenone, ಆಯ್ತಾ. methyl vinyl ketone, ಲ್ಯಾಂಬ್ಡಾ ಮ್ಯಾಕ್ಸ್ ಎಲ್ಲ ಎಷ್ಟಿರುತ್ತೆ 270, 290, 280 ಈ ರೇಂಜ್ ಅಲ್ಲಿ 293, 319 ಈ ರೇಂಜ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಟೈಪ್ ಒಂದಿದೆ ಅದ್ರಲ್ಲಿ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ಫಾರ್ aromatic and next 5 to 5 star is different in aromatic. 5 to so in aromatic or aromatic, these are heteroaromatic. The pyrrole say heteroaromatic and this is aromatic compound. In this type of compounds, so molecules give P band. This type of molecules P band. So absorption peaks between 230 to 270 nanometer. 270 so millimicron. When chromophoric group is attached to the benzene ring, group attach ಆಯ್ತು ಅಂದ್ರೆ longer wavelength ಅಂದ್ರೆ energy is longer wavelength is request longer wavelength than the intense cable benzene ring ಆಯ್ತಾ. ನೋಡಿ ಫಸ್ಟ್ ಈ ರೇಂಜ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಯಾವುದು P bands ಆಯ್ತಾ. when chromophoric group is attached to the benzene ring, the P bands are longer wavelength, longer wavelength, more intense K bands in the long, more intense K band. For example, K band appears at 244 millimicron. some maximum so next ಅದೇ B band 82. So this K bands appears as 244, B bands appears at 282. So maximum 450 absorbance 450. What about this absorbance? 1200 due to higher. This is higher wavelength. It appears at 450. A, B and R bands appear in the spectrum of aromatic compounds are out of K, B and R bands which appear in the spectrum of an aromatic compound. Aromatic compound ಅಲ್ಲಿ ಯಾವುದು appear ಆಗುತ್ತೆ? K, B, R. Aromatic compound ಯಾವುದು? Aromatic compound. R band appear at longer wavelength, for example in acetophenol. N2 pi 5 star ಹೇಳಿದ್ರಿ, N2 pi star R band. So acetophenol R band. So N2 pi star. So appear at 390 em micron. So R band. While K and B bands, what about K and B bands? 240 millimicron and 278 millimicron. Whereas K band 240, B band 278 respectively. The fine spectrum of B in case of substituted aromatic compound. B ಯಾವಾಗ ಬರುತ್ತೆ? Substituted ಆಗಿದ್ರೆ B band appear in intensity is enhanced by substitution. Any chromophoric group or polarity of the solvent. ಯಾವ solvent use ಮಾಡ್ತೀವಿ ಅದರ polarity of the solvent. Polarity of the solvent. So this is about K, B and R bands. So pi to pi star ಅಲ್ಲಿ benzene, acetophenol ಎಲ್ಲ ಇರುತ್ತೆ. Next transition followed probability ಅಂತ ಇರುತ್ತೆ. So there are two types. ಇದು important. Allowed transition, forbidden transition. Allowed transition and forbidden transition. What is allowed and forbidden transition? The transition associated with extinction coefficient. Extinction coefficient values more than 10 to the power of 4 are usually called allowed transition. Allowed transition. The generally due to allowed transition is pi to pi star. For example, in butadiene, butadiene 1,3, butadiene 1,3 is nothing but example. This is the example allowed transition. Example, absorption at 127 micron. So absorptive maximum is 12,000. Absorption maximum is 21,000. 21,000 is allowed transition. The transition associated with maximum values less into the power of 4 are usually forbidden band, are usually called into the power of 4 ಇರುತ್ತೆ. Forbidden molar absorptivity coefficient is less than 10 to the power of 4. extinction of one electron from the lone pair present bond in pi star. So this is actually forbidden in the acetone. N2 actually forbidden antibonding function. For example, N2 transition is nearly 300 millimicron in carbonyl compounds, with molar absorptivity value is equal to 10 to 100 only. That's why it is forbidden. N2 pi star ideyala. That's why it is forbidden. The absorptivity is over 20,000, 50,000, then it is allowed. But here very absorptivity coefficient, that's why it is forbidden transition. The allowed or forbidden transition is related to two factors. There are many factors are geometry. Geometry is very important. Geometry of allowed and transition are followed related with factors there. Transition compared to less symmetrical molecules. For example, benzene is a highly symmetrical molecule. Correct? Thus, many restrictions are applied to the electron transition of this molecule. Therefore, its electronic absorption spectra is very simple. No symmetry restrictions are applied to the electron transition for totally unsymmetrical molecule. No symmetrical restriction. Hence, transition may be observed among all of its unfilled molecular orbitals. This leads to complex electronic absorption spectra for such substances. A large number of organic compounds absorb UV visible light. Following the factors are important to decide whether the transition is allowed or forbidden for this molecule. The ground state geometry of the molecular orbital. So geometry and excited state geometry, ground state and excited geometry. Excited ground state of the molecular orbital and the excited geometry of the molecular orbital. Next, orientation of the molecule. Orientation, adu kuda important. Yav direction orient, applied radiation direction orient ಆಗಿದೆಯಾ ಅಥವಾ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ that in transition, if this geometry of ground state, geometry of ground state geometry of excited state and orientation of electric dipole of the incident light. That if these three factors have an appropriate symmetry relationship, then the allowed transition will be resulted. If symmetry, if these three are appropriate, if these three are appropriate symmetry relation, then it is allowed transition. Otherwise not, means forbidden. So next, absorption of dyes. So last topic in this unit, S2, DH, DS2. ಆಯ್ತಾ. ಪ್ಲಸ್ ಪ್ಲಸ್ ಇರುತ್ತೆ. ಇನ್ನೊಂದು ಆಂಟಿಬಾಡಿ ಪ್ಲಸ್ ಮೈನಸ್ ಆಯ್ತಾ. ಪೈ ಪ್ಲಸ್ ಪೈ ಆರ್ ಸೈನ್ ಆಯ್ತಾ. ಪೈ ಪ್ಲಸ್ ಮೈನಸ್ ಪೈ ದಟ್ ಈಸ್ ಪೈ 1 ಆರ್ ಸೈನ್ higher energy. This is lower in energy. Plus minus plus energy. This is plus. Higher energy, ಇನ್ನೊಂದು lower energy. ಒಂದು double bond ಅಲ್ಲಿ. If in a two double bonds are conjugated, is called butadiene. ಬ್ಯೂಟಾಡೈನ್ ಕೇಸಲ್ಲಿ ಏನಿರುತ್ತೆ, 4 pi bonds 4 pi bonds ಒಂದು ಎಲ್ಲ ಗ್ರೌಂಡ್. ನೆಕ್ಸ್ಟ್ ಎನರ್ಜಿ ಲೆವೆಲ್ ಎರಡು. ಸೊ ಇನ್ನೆರಡು ನೋಡಿ, psi 1 ಅಲ್ಲಿ ಏನಿದೆ, ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ psi 1. psi 1 can be represented like this. psi 1, see, plus above, all are plus. psi 1 can be represented as follows. There is no nodal plane. All the four because this minus is plus. What about side plane is there? Minus. ಆಯ್ತಾ. And this is plus, this is minus. So this is side plane. Plane ಇಲ್ಲಿ ಪ್ಲಸ್ ಮೈನಸ್ ಅನ್ನು ನೋಡುತ್ತೆ, ಮೈನಸ್ ಆದ್ಮೇಲೆ ಇಲ್ಲ ನೋಡುತ್ತೆ. Planes. Two nodal plane. One nodal plane. Here. One nodal. Here no nodal plane. 0. No nodal plane. One more is there, psi 4, total 4 pi electrons. That's why it is psi 4. Here 3 nodal planes is there. See, plus minus. Total 3 nodal plane. In which molecule? This is the molecular chain. 1,3 ಸೊ ನೋಡಿ, ಈ ಎನರ್ಜಿ ಲೆವೆಲ್ನ ಈ ತರ ಬರ್ಕೋಬಹುದು. ಸೊ ದಿಸ್ ಇಸ್ ಆಯ್ತಾ, 1 2 3 4 ಲೈಕ್ ದಿಸ್ ಆಯ್ತಾ. ಅದೇ ಎಥಿಲಿನ್ ಯೂನಿಟ್ ಆದ್ರೆ ಇದು 1 2 3 4. ಅದೇ ಎಥಿಲಿನ್ ಆದ್ರೆ ಒಂದು ಬಾಂಡಿಂಗು, ಇನ್ನೊಂದು ಆಂಟಿ ಬಾಂಡಿಂಗ್. So this is ethylene unit, double bond ethylene. So ethylene case ಅಲ್ಲಿ ಇದು plus ಆಯ್ತಾ. This is also 1 pi bond, this 1 pi bond. This is psi 1, psi 2, psi 3, psi 4. How many electrons is there in butadiene? ಇಲ್ಲಿ 2 electrons ಇದೆ, ಇಲ್ಲಿ 2 electrons ಇದೆ. ಡಬಲ್ ಬಾಂಡ್ ಅಂದ್ರೆ 2 electrons. 5 ಎಷ್ಟಿರುತ್ತೆ? 2 electrons. So 2 electrons. Ethylene alli only 2 electrons. This is antibonding. This is ethylene. This is 1,3 1,3-butadiene molecular structure. The bonding. Here we call this is highest occupied molecular orbital, HOMO. Lowest unoccupied molecular orbital, LUMO. So ಇವೆಲ್ಲ ನೇಮ್ಸ್ ಗೊತ್ತಿರಬೇಕು ನಮಗೆ. HOMO ಅಂದ್ರೆ highest occupied molecular orbital. LUMO is nothing but lowest unoccupied molecular orbital. If you observe light radiation, there is a transition from HOMO to LUMO here. There is a transition from psi 2 to psi 3. This is called pi to pi star transition. Pi to pi star transition. This is pi 2 to pi 3 transition. So molecular level energy hinge adaga the light one of the electrons goes to promote into higher energy level from ground state. From ground state. The ground state in ಏನಾಗಿದೆ lighter radiation to pi 2 to pi 3. So this is actually 1,3-butadiene. 1,3-butadiene. In molecular orbital diagram, VS theory, part to VSPR. So this is VSPR theory prakara. ನಮ್ಗೆ ಗೊತ್ತಿದೆ. So what is VSPR theory? This pi star, this pi star, these 2 electrons, this is HOMO. Here no electron, LUMO. This total 4 alva irodu 1 2 3 4 aita. This is pi 1, pi 2, pi 3 and pi 4. This is star. We have antibonding. Idya? So this is pi plus pi, this pi plus pi, and this is pi minus pi, antibonding. Aita? This is pi star plus pi star bonding and pi star plus pi star. This is pi star minus pi star. Right? So here, what are the transitions are possible here? Minus to minus. See, this is one transition from here to here. Pi 2 to pi 4 star. So here. So again, minus same symmetry transition. So that's why I ಹೇಳಿದೆ first UV spectroscopy symmetry should be ನೋಡಿ ಇಲ್ಲಿ bonding ಅಂದ್ರೆ ನೋಡಿ symmetry ಹೆಂಗಿರಬೇಕು ಅಂದ್ರೆ ಇದು minus plus minus ಇದನ್ನ ಬರ್ಕೊಳ್ಳಿ. ಇದನ್ನ ಬರೆದಾಗ ನೀವು plus minus symmetry plus minus ಇದು symmetry should be same symmetrical. ಆಯ್ತಾ? 2 5 4 ಟ್ರಾನ್ಸಿಷನ್ ಮತ್ತೆ ಸಿಮೆಟ್ರಿ ಇರಬೇಕು ಸೇಮ್. ಅದೇ ರೀತಿ ಇಲ್ಲಿನ from here to pi 1 to pi 2 star. pi 1 to pi 2 star. pi 1 to pi 2 star. ನೋಡಿ ಇಲ್ಲಿ this is plus, this is also star. Pi star plus pi star. See, plus symmetry. pi 1 to pi 2 star. pi ಹೇಗೆ ತರ ಟ್ರಾನ್ಸಿಷನ್ ಆಗುತ್ತೆ ಅಂತ ಬ್ಯೂಟಾಡೈನ್ ಅಲ್ಲಿ how it is. So this is highest molecular orbital, highest occupied molecular orbital. HOMO is highest occupied, highest electron ಯಾವುದರಲ್ಲಿದೆ occupied molecular orbital ಇದು HOMO. What about LUMO? This is LUMO. This HOMO here, or this is LUMO, or this is HOMO here, or this is LUMO for second transition. First transition HOMO to LUMO, second transition this one. Pi 2, pi 4, pi 1 to is pi 3. Pi 1 to pi 3. Pi 1 to pi 3. Okay. So these are the in summary ಏನಂದ್ರೆ ಫಸ್ಟ್ ಮೋಸ್ಟ್ ಆಫ್ ದಿ ಆರ್ಗ್ಯಾನಿಕ್ ಮಾಲಿಕ್ಯೂಲ್ ಫಸ್ಟ್ ಸಮ್ಮರಿ ಅಲ್ಲ ಜಸ್ಟ್ ಡಿಸ್ಕಸ್ ಸಮ್ಮರಿ ನೋಡಿ ಯಾವುದೇ ಒಂದು ಕಾಂಪೌಂಡ್ ನ ತಗೊಳ್ತೀವಿ ಇಲ್ಲಿ ಕೋಯದಲ್ಲಿ ಒಂದು ಲೈಟ್ ಪಾಸ್ ಮಾಡ್ತೀವಿ this is transmitted light. It mainly depend upon concentration of the solution and thickness of the coin T, and absorption, outside absorption is directly proportional to F naught CT. This is IT by IT, I naught by IT, incident by this one, that's equal to what? So how it varies, ಹಿಂಗೆ ವೇರಿ ಆಗುತ್ತೆ I naught IT ನ ರಿಲೇಶನ್ಶಿಪ್ ಏನಂದ್ರೆ, so I is equal to I naught incident light is equal to e to the power of CT, exponentially decreases. So concentration ಮತ್ತೆ thickness it decreases exponentially. Incident light exponentially ಆಗಿ decrease ಮಾಡುತ್ತೆ concentration and thickness of the coil. So this is these Lambert's law combined. ಒಂದು concentration ಹೇಳೋದು Lambert's law, thickness ಹೇಳೋದು Beer's law. Beer's ಮತ್ತೆ Lambert's law combine ಆಗಿ ಏನ್ ಕರಿತೀವಿ? Beer's Lambert's law. Beer's Lambert's law ಏನ್ ಹೇಳ್ತಾರೆ? So incident light decreases concentration, incident light decreases with exponentially with respect to concentration and thickness. This is Beer's Lambert's law. So many so in organic molecules usually sigma, pi and non-bonded. Here types sigma to sigma star I already told, n to sigma, and then pi to pi star transition to pi star energy. So this is increasing energy. This ಹೆಂಗಾಗುತ್ತೆ sigma to sigma star? How many types? Sigma diagram ಅಲ್ಲಿ ಬಿಟ್ಟು ಹೇಳ್ತಿದ್ದೀನಿ ನಾನು ಎನರ್ಜಿ ಲೆವೆಲ್ ಆಯ್ತಾ. ಸಿಗ್ಮಾ ಟು ಸಿಗ್ಮಾ ಸ್ಟಾರ್ ಯಾವ ಮಾಲಿಕ್ಯೂಲ್ ಎಕ್ಸಾಂಪಲ್ CS4 ಸಿಗ್ಮಾ ಬಾಂಡ್ಸ್, pi to pi ಇರಬೇಕಂದ್ರೆ ನಾನ್ ಬಾಂಡೆಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರಬೇಕು ಅಸಿಟೋನ್, ಯಾರು ಆಲ್ಸೋ ಕಾಲ್ಡ್ A ಬ್ಯಾಂಡ್ ಆಯ್ತಾ. ಸೊ ದಿಸ್ n to sigma ಯಾವ ಬ್ಯಾಂಡ್ ಅದು? B ಬ್ಯಾಂಡ್ ಆಯ್ತಾ. ಹೇಳಿದ್ದೀನಿ n to pi star are also called which band? n to pi star. These are the types of transition. ಈ types of transition ಇರುತ್ತೆ. ಈ types of transition ಅಲ್ಲಿ forbidden ಯಾವುದು? UV ರೀಸನ್ ಬಿದ್ರೆ ಬೀಳಲಿಲ್ಲ, ರೀಸನ್ ಅಲ್ಲಿ ಬರಲಿಲ್ಲ ಅಂದ್ರೆ forbidden. n to pi star this is forbidden actually. You only 10 to 100 if not intensity. What about allowed? Pi to pi star is allowed because it belongs to UV region, that is more than 10 to the power of 4. More than 10 to the power of 4. Forbidden and allowed. And symmetry. So ನಾನು ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೀನಿ, ಓಮೋ ಲೂಮೋ ಏನಿರಬೇಕು ಅಂದರೆ ಸೇಮ್ ಸಿಮೆಟ್ರಿ ಇರಬೇಕು. ಪ್ಲಸ್ ಇದ್ರೆ ಇಲ್ಲೂ ಕೂಡ ಪ್ಲಸ್ ಮೈನಸ್ ಇರಬೇಕು, ಟ್ರಾನ್ಸಿಷನ್ ಆಗಬೇಕು. ದಟ್ ಈಸ್ ಸಿಮೆಟ್ರಿ ಅಲೌಡ್. ಸಿಮೆಟ್ರಿ ಅಲೌಡ್, ಜೊಮೆಟ್ರಿಕಲಿ ಅಲೌಡ್ ಇಸ್ ಫಾರ್ಬಿಡನ್. ಸಾರಿ, ಅಲೌಡ್ ಟ್ರಾನ್ಸಿಷನ್ ಆಗಬೇಕಂದ್ರೆ ಸಿಮೆಟ್ರಿ ಕರೆಕ್ಟ್ ಇರಬೇಕು. ನೋಡಿ, ಇದು ಪ್ಲಸ್ ಪ್ಲಸ್ ಇದ್ರೆ ಇಲ್ಲೂ ಕೂಡ ಪ್ಲಸ್ ಪ್ಲಸ್ ಇರಬೇಕು ಟ್ರಾನ್ಸಿಷನ್ ಆಗಬೇಕಂತ. ದೆನ್ ಇಟ್ ಈಸ್ ಅಲೌಡ್, ಫಾರ್ಬಿಡನ್ ಅಂಡ್ ಅಲೌಡ್. ಈ ಎಥಿಲಿನ್ ಮಾಲಿಕ್ಯೂಲ್ ಅಲ್ಲಿ ಹೇಳಿದೀನಿ 4 ಇರುತ್ತೆ ಈ ತರ ಎಲ್ಲ. ಆಲ್ ಆರ್ 4, ನೋ ನೋಡಲ್ ಪ್ಲೇನ್, ಓಮೋ ಲೂಮೋ, psi1, psi2, psi3 and psi4. Total electrons is there, butan ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್. ಈ ಕ್ಲಾಸಲ್ಲಿ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದ್ರೆ ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್. ಡೌಟ್ ಇದ್ರೆ ಕೇಳ್ಬೋದು. ಎನಿ ಡೌಟ್? ನೋ ಡೌಟ್? ನಾನು ಇನ್ಫಾರ್ಮ್ ಮಾಡ್ತೀನಿ. ಸೆಂಡ್ ದ ಲಿಂಕ್. ಲೆಟ್ ನೋ ಫಸ್ಟ್ SLM. ಅದ್ರಲ್ಲಿ ಏನಾದ್ರು ಡೌಟ್ ಏನಾದ್ರು ಬೇಕು ಇದ್ರೆ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಏನ್ ಮಾಡಿ ಕ್ಲಿಯರ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಅಥವಾ ಪ್ರಾಕ್ಟಿಕಲ್ ಬರ್ತಿರಲ್ಲ ಅವಾಗ ಕ್ಲಿಯರ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಅಟ್ ಎನಿ ಟೈಮ್ ಯು ಕ್ಯಾನ್, ನೋ ಪ್ರಾಬ್ಲಮ್. ಸೊ ಮೆಸೇಜ್ ಏನಾದ್ರು ಮಾಡಿ ಅಥವಾ ನಾವು ಆನ್ಸರ್ ಮಾಡಿರ್ತೀವಿ. ಸೊ ನೋ ಪ್ರಾಬ್ಲಮ್. ನಾವು ವಿಲ್ ಎಂಡ್ ದಿ ಕ್ಲಾಸ್. ಥ್ಯಾಂಕ್ ಯು.